This video is on the topic of electronegativity. So the aims of this video are firstly to be able to define electronegativity. That electronegativity is one of those words that you have to be able to give a definition for if they ask for it in an exam. Know the trend and be able to explain the trend of electronegativity across period 3, and again the same but down a group. There's no specific group, but it's just down a group. So electronegativity is one of those words you have to be able to define, and it's always worth 2 marks. So the full definition is electronegativity is the power of an atom to pull electron density or electrons towards itself in a covalent bond. And there are 2 parts of this answer that gets the 2 marks. The first one is this first bit, the power of an atom to pull electron density or to pull electrons towards itself. That is 1 mark. The second mark is for adding that it's in a covalent bond. It's not in any other type of bond, it's only in a covalent bond that electronegativity really matters. So in the specification that you follow, it focuses on period 3 of the periodic table. So this is period 1 at the top with hydrogen and helium, period 2 starts with lithium, and then period 3 is the one that starts with sodium. So that's the one that the specification focuses on in terms of asking questions and what you have to learn about. So here's period 3, and the first thing I'm going to do is cross out argon. And the reason for that is that argon generally does not form covalent bonds, and so cannot have an electronegativity, as an electronegativity is defined as being in a covalent bond. Now as you go across period 3, the electronegativity increases. Now when trying to explain this, you've got to think about why electrons would be attracted to one atom more than another in a covalent bond, and electrons are attracted to protons. As you go across this period, the number of protons in the nucleus increases. You can see that it goes from 11 to 12 to 13, 14, 15, 16, 17. It increases by 1 each time. So the number of protons increases. Another thing that would affect the electronegativity is how many shells of electrons there are, i.e. how far away from the nucleus the electrons would be. Now if you're in the same period, the electrons are added to the same shell. So sodium, it would be there, and for magnesium it would also be in the same shell. So the electrons are getting no further away from the nucleus, so that doesn't have any effect. There are also no extra electrons inside, further in from the electrons that can shield them from the nucleus. There are some, but there are no extra ones as you go across this period. So in summary, the reason why electronegativity would increase across a period is because of increasing nuclear charge, i.e. the number of protons increases, and you have the electrons are in the same shell as you go across, and there is no extra shielding as you go across. And that's what you'd put in a answer explaining why electronegativity increases across a period. Now if we move to what happens down a group instead, and for this example I'm going to use group 1 here. So there's group 1. As you go down a group, electronegativity decreases. Now you may say, well, as you go down a group, the number of protons increases, so why does the electronegativity increase? Because previously we said the electronegativity is to do with how many protons there are. Now that is true, but there are other factors involved here in that there are extra shells of electrons. So for lithium, you have a shell of electrons. For sodium, there's an extra shell of electrons. For potassium, you have another one. And so the electrons are getting further and further away from that nucleus in the middle. And that has a bigger effect than the number of protons increasing. The other effect is that now there are extra electrons further inside the shell of electrons that are on the outside, and so the electron shielding also increases. So to summarise this, you'd say even though the proton number is increasing, the electrons are further from the nucleus. And there is more shielding as you go down the group. If you are still struggling with electronegativity, then please come and find me or email me.